All right, let's just dive straight into this explainer. If you've been paying any attention at all to the crypto space lately, you know the game is changing, and it's changing fast. Exchanges and DeFi platforms, they've become incredibly sophisticated at detecting linked accounts. Getting flagged isn't just a minor inconvenience anymore. It's a massive risk. We're talking frozen funds, completely forfeited airdrops, or just permanent bans. So today, we're unpacking a comprehensive 2026 guide on exactly how the surveillance actually works, and we'll break down the highly technical playbook that serious operators are using to survive the crackdown. So why do 90% of airdrop farmers get caught? It's literally the question keeping crypto operators up at night. Why do so many people ultimately lose their funds or totally miss out on massive allocations to the very platforms they're trying to game? I mean, you might think you're being careful, right? You're using different wallets, maybe you threw a VPN on. But the reality is, the platforms you're interacting with are running a massive, practically invisible surveillance state. They're actively hunting for the tiniest cracks in your operational security. And as our source material reveals, most basic setups are pretty much just waving a giant red flag at these detection algorithms. Actually, I want you to just let this number sink in for a second. 1.3 million. That is the number of individual wallet addresses that were completely purged by the Layer 0 protocol during their recent airdrop Sybil detection phase. And look, they aren't alone. ZK Sync filtered out over 600,000 addresses themselves. This just brilliantly illustrates the severe consequences of bad OPSEC. Because of the combination of off-chain tracking and on-chain behavioral analysis, if you aren't perfectly isolating your accounts, you're not just risking one single wallet, you are risking your entire operation. Now that we know exactly what's at stake, here is our roadmap for the explainer. First, the multi-account crypto game. Second, how platforms track you. Third, comparing browser solutions. Fourth, building secure crypto identities. And finally, the fatal mistakes you absolutely have to avoid. Okay, kicking things off with part 1, the multi-account crypto game. You know, it's really easy to assume multi-accounting is just for malicious actors, but there's a huge variety of legitimate, highly strategic use cases here. Airdrop farming is the most obvious one, of course, operating dozens of wallets to qualify for new protocol tokens. But look at risk management for a second. Serious traders actively separate their accounts to isolate spot trading from futures or just to protect themselves in case a single centralized exchange goes under. Then you've got DeFi yield optimization. A lot of protocols cap their highest APY to the first few $1,000s deposited. So by splitting funds across multiple wallets, operators can capture that maximum yield multiple times over. Whether it's bypassing NFT minting limits or maximizing testnet participation rewards, managing multiple identities is basically core infrastructure in modern crypto. Which brings us right into part 2, how platforms actually track you. All right, the most pervasive method here is something called browser fingerprinting. Think of this as your device's digital DNA. Modern crypto platforms are deploying the exact same underlying tech used by giants like Facebook and Google. The absolute second you connect, they're scraping your canvas hashes and WebGL render strings. Basically, they're seeing exactly how your specific graphics card draws hidden images. They grab your audio context, your installed fonts, your screen resolution, even your time zone and language settings. So if you log into 2 different accounts and this highly unique fingerprint matches, bam, the platform instantly knows both accounts belong to the exact same person. And that fingerprinting, it builds into this whole web of invisible tripwires. Because it's not just the fingerprint. Exchanges are logging every single IP address and cross-referencing them. If you switch accounts in the same browser, your persistent cookies and local storage are going to betray you. If you accidentally submit the same ID document to 2 accounts on an exchange, well, you're caught immediately. On-chain, Sybil detection algorithms are constantly analyzing your funding patterns and the exact timing of your transactions. And incredibly, even if you think you're safe using a proxy, WebRTC and DNS requests can just leak your real underlying IP address straight to the platform's servers anyway. Moving right along to part 3, comparing browser solutions. First off, we've got to bust a massive myth here. Basic setups, they absolutely do not work. If you're just creating separate Chrome or Firefox profiles, they all share the exact same hardware fingerprint and IP address. You will be instantly linked. And what about a VPN combined with incognito mode? Honestly, it's basically like putting on a hat, but leaving your face fully exposed. Sure, it changes your IP, but VPN IPs are constantly flagged by exchanges anyway. Plus, incognito mode does absolutely nothing to change your hardware fingerprint. And because it wipes your data every time, you lose the persistent wallet sessions you actually need to operate efficiently. So, this brings us to the ultimate showdown in advanced setups: local anti-detect browsers versus true cloud hardware isolation. Tools like multi-login and go-login are super popular because they heavily spoof your fingerprint to try and trick those detection algorithms. Now, they run locally on your machine, which does give them a solid level of Sybil resistance, but advanced analysis can definitely sometimes spot those spoofed values. On the other hand, the source details cloud browsers like Sendwin, instead of trying to fake a fingerprint on your computer, it runs the entire session on a completely separate virtual machine in the cloud. This gives you a real hardware fingerprint, native WebRTC leak protection, and literally zero local footprint on your actual machine. All right, let's get into part 4, building secure crypto identities. Think of this as your digital heist playbook. The source material lays out 5 exact steps you've got to follow. First, you plan your identity architecture, really mapping out how many identities you actually need and what geographic regions they should be in. Step 2 is setting up those browser profiles, locking in a unique fingerprint and a dedicated residential proxy for every single one. Step 3 is where a lot of people mess up. You must fund wallets independently. If your 10 distinct wallets all receive Ethereum from your one main exchange account, game over, you're caught. Step 4 requires you to diversify your on-chain activity. You need to interact with different smart contracts at different times using different token amounts. And finally, Step 5 is just maintaining that rigorous operational security going forward.
And that leads us perfectly into our final section, Part 5, Fatal Mistakes to Avoid.
Because here's the thing, perfect browser isolation means absolutely zero if careless human errors unravel the whole shebang. Let's rapidly run through the sloppy operational mistakes that get operators permanently banned. Setting up exchange accounts with lazy emails like trader1@, trader2@, and trader3@, that's an obvious pattern that algorithms flag in a heartbeat. Doing things simultaneously, like claiming airdrops across 10 wallets at the exact same minute, is a massive red flag. Interestingly, changing your browser fingerprint between sessions for the exact same account is actually way more suspicious than just keeping it consistent. And like we mentioned earlier, reusing KYC documents or directly sending funds between your own supposedly distinct wallets will immediately destroy all that isolation you carefully built. So the absolutely crucial takeaway here is this. Your brilliant browser disguise off-chain, it has to be matched by a totally unique alibi on-chain. If your wallets engage in circular fund flows, say wallet A sends to wallet B, which sends to wallet C, which then sends right back to your main account, the blockchain's permanent public ledger is going to expose you, no matter how good your anti-detect browser is. On-chain Sybil detection doesn't care about your browser choice. It purely analyzes your behavior. And look, the game is only getting harder from here. If we look ahead to the evolving threats coming in 2026 that the source notes, simple fingerprint spoofing is rapidly becoming obsolete. We're now facing zero-knowledge proof identity systems like WorldCoin and Gitcoin Passport that are designed to verify genuine personhood without giving up your data. Plus, AI-powered Sybil detection models can now analyze coordinated behavior across thousands of addresses all at once. You've got firms like Chainalysis tracking identities across multiple, entirely different blockchains. And on top of all that, big tech is pushing web environment integrity APIs, tools that let websites definitively verify if a browser has been tampered with, making traditional local anti-detect browsers highly vulnerable. Which really leaves us with this final kind of profound question. In an era of relentless AI detection, cross-chain tracking, and ZK proofs, is true digital anonymity actually still possible in the Web3 space? The arms race between these surveillance algorithms and privacy tools is accelerating faster than we've ever seen. While tools utilizing real cloud hardware isolation and strict behavioral discipline offer a path forward today, the very definition of digital identity is literally being rewritten right before our eyes. It's a fascinating, high-stakes evolution, and it's for sure one we're going to keep explaining as the tech develops.